Hi everyone. In this video, we are going to discuss the solution of three-sum problem. Let's try to read the statement first. We are given an array and a target. We need to find all the triplets such that their sum is equals to target. And the indices of triplet must be different. Also, the solution must contain unique triplets. Let's try to understand this through an example. If we have these array elements and my target is 0, so I can select 3, 8 and minus 11. Sum of all these elements is equals to 0. So can I select 3 and this 8 and 11? No, because we need to consider only the unique triplets. So it is nothing but a repetition of already considered triplet. I need to avoid this. After this I have one more triplet, minus 6, minus 1 and 7. Sum of this triplet is again 0. So that is why in this case we are only having the two answers. Now think about the brute force approach. The question is asking to find triplets. That means we have to consider all the triplets. And in order to consider all the triplets, I need to have these three for loops. This I is basically representing the index for element 1, j is representing the index for element 2, and k is representing the index for element 3. So if the sum of these three elements is equals to target and it is not repeating, so in that case I can print my answer, and to avoid repetition I need to add this triplet in my set. Now what will be the overall time complexity of this approach? It is going to be big O of n cube. So this is a very high time complexity. Now we need to optimize this. So in order to optimize, let's have a look at this equation. Array of I plus array of j plus array of k, and it is equals to target. So can we modify this equation like this, that array of k is going to be target minus, take these two values on the right hand side, array of I and array of j. That means the value of third element should be nothing but target minus array of I minus array of j. So in order to find the value of third element, instead of looking in the array, can we really use hash map? Yes. So we can have some optimization by using hash map. Let's try to consider this. So this is nothing but my third element. What should be the value of third element? Target minus array of I minus array of j. So I'm going to look this third element in the hash map. Consider one example. The elements are 2, 1, minus 2, 2, minus 1, 3, 4, 5. And my target is 6. Now my step number 1 is going to be, I need to create a hash map which is going to store the frequency of every element. So 2 is present. How many times? 2 times. Let's consider one more 2. So it is present 3 times. 1 is present once, minus 2 is present once, then minus 1, 3, 4 and 5. Alright. So after creating this hash map, now I will check. I will consider all the possibilities for I and j, all the pairs of I and j. Let's say I'm fixing I here, and as of now my j is fixed on 1. So I'm already considering these two values, 2 and 1. And then I need to find the third value, which must be equals to target minus this value. Alright. So 2 is already considered. So I need to decrease the frequency of 2. 1 is already considered. So I need to decrease the frequency of 1. Now I am looking for my third element, that must be equals to target minus array of I, that is 2, minus array of j, that is 1. So I'm looking for 3. So instead of checking it in the array, I will just simply check in the hash map. Is 3 present in the hash map? Yes. And is the frequency of 3 is greater than 0? Yes. So definitely I can use this triplet. Array of I, array of j, and this value is going to be your third element. So we have a valid triplet. Now after this, I need to increase the value of j. That means 1 is now available. Increase the frequency. Minus 2 is being used. So decrease the frequency of minus 2. Now I'm looking for the third element. The value of third element should be target minus array of I minus array of j. So it is 6. So 6 is not present in the hash map. That means we are not getting a valid triplet here. So increase your j. Now minus 2 is free. Increase the frequency of minus 2 and decrease the frequency of 2. Alright. Again the third element. The value of third element should be 6 minus 2 minus array of j. Again 2. So I'm looking for 2. Now I will check if 2 present in the hash map. Yes. And the frequency of 2 is greater than 0. Yes. That means I can use this element. And we are having another triplet. Array of I, array of j, and the current element, the third element, is again 2. So similarly, let's have one more iteration. Now I need to increase the frequency of 2 and I need to decrease the frequency of minus 1. Now I will check what should be the value of k. Target minus array of I minus array of j. So that is actually 6 minus 1, it is 5. Is 5 present in the hash map? Yes. And the frequency of 5 is greater than 0. So I can consider this element and we have another triplet. 2, minus 1 and 5. Alright, so in this way I can found all the triplets. So in order to have the unique triplets, I need to consider a set, right? And these elements will be arranged in sorted order. Like if there is any repetition, if you are considering minus 1, 2 and 5, you can consider them like this now. So in that case, we have to check whether it is already present or not. So that is why you need to consider the sorted order. Alright, what will be the time complexity of this approach? Now we are considering all the possibilities of I and j, all the pairs of I and j. So the time complexity is going to be big O of n square. And the space complexity is going to be, I'm using one hash map, big O of n. And in order to have the unique triplets, I need to use a set. So big O of m. This is going to be your overall time and space complexity. Now the question arises that can we really optimize this space complexity? Can we really do this question in constant space complexity and of n square time complexity? So definitely. How to do this? It is going to be my optimization 2, which is based on two-pointer approach. So it is a prerequisite for this question. You must be aware of this two-pointer approach. Now, in order to apply two-pointer approach, I need to first sort the array. So the array will be present in sorted order. Now let's see how to apply this two-pointer approach. I'm going to fix one element and then I need to check for j and k. So can I say that my equation was array of I plus array of j and array of k, it is equals to target. And we are fixing array of I. That means I'm looking for array of j plus array of k equals to, this is target minus array of I. So I'm looking for a pair whose sum is equals to this. We have already solved this problem, and the name of this problem was two sum problem. We are looking for a pair such that their sum is equals to target minus array of I. Alright, but here we are going to solve this problem using two pointer approach. So let's see. So array of I is fixed on -1. So I am looking for target minus 6 minus -1. I am looking for 7. I'm looking for a pair whose sum is equals to 7. Now initialize j with I plus 1. Initialize k with the last pointer, with the last index. Now I need to check the sum of these two elements. Is this sum equals to 7? No, it is less than 7. 6 minus 1, it is 5. So I need to increase j. Now again I will check 6 plus 1. Is the sum equals to 7? Yes. That means we found one valid triplet. It is going to be -1, 1 and 6. Now we have considered the value of j and k. Increase j and decrease k. Again 2 plus 4, array of j plus array of k. 2 plus 4, it is 6, but I was looking for 7. So the value is less than 6. The value is less than 7. Then I need to increase j. Again 2 plus 4, this is going to be 6. Less than 7, I need to increase this. Also, if the duplicates element are present, and I simply say that I need to ignore these duplicate elements. So just ignore them because we have already considered this 2 value. Just ignore this. J will be here and k will be here. Now sum of these two elements is equals to 7. Yes. That means we found another pair. -1, 3 and 4. After this, we need to ignore the duplicates, right? So this is again 3. So I need to ignore this. Move j ahead. We have 4. Yeah, this is different. Similarly for k, I need to ignore the duplicate values. 4 is present here. Ignore this. Now this is a different element. Yes. Now we have considered all the values of j and k, right? Since j is greater than k, so now we can stop looking for the answers when I is equals to -1. All right. So after this, we have discovered all the possibilities when array of I is -1. All right. After this, I need to increase the value of I. But see again, -1 was already present. Now you are again considering this value -1, right? So it is a case of duplicates. Again there will be a repetition. So similar elements are present, just ignore this value and increment the value of I. So if I is having a different value, then again you need to initialize j and k, and again you need to apply two pointer approach. So in this way you are going to get all the unique triplets which are having their sum is equals to target. All right, let's try to code this approach. So my step number 1 is going to be, I need to sort the array. Arrays dot sort A. After this, we can fix I anywhere from 0 to n. Now, if I is 0 or array of I must be different from array of I minus 1. Remember the case of -1 and -1, right? Array of I is having the same value. Remember this case? So I'm just saying that array of I should be different from the previous value. Only in that case you can consider the answer. Now we have to apply the two pointer approach. J will be initialized with I plus 1 and K will be initialized with n minus 1. So while J is less than K, yes, and my new target is actually equals to target minus array of I. Now I will check if sum of these two elements, array of J and array of K, if it is equals to target, then what should we do? And if this is less than target, then what should we do? Else is representing the sum is greater than target, then what should we do? Right. So if this is less than target, that means I have to increase the value of J. Otherwise, I have to decrease the K pointer. Now, array of J plus array of K, if this is equals to target, that means we got our answer. You can print this. Array of I plus array of J plus array of K. Now after this, I have to increase J and I have to decrease J. I have to decrease K. Now forget, we have to consider the case of duplicates, right? We have to ignore the duplicates. So for this, what I am saying is that while J is less than K and you are getting the same value, array of J is equals to array of J plus 1. If same value is present, then you can just ignore this. Just do J plus plus. Similarly, if array of K is equals to array of K minus 1, it is equals to its previous value, then also I need to ignore this. Simply do K minus 1. Just simply ignore this. Okay, so this is the case of ignoring duplicates. Alright, I think that's it. And let's try to run this. Java main.java. Java main. Yes, so we are getting these two triplets, minus 11, 3, 8, minus 6, minus 1 and 7. So no duplicacy is present in our answer. Now, what will be the overall time complexity of this approach? So I am fixing this. First of all, we are sorting the array. So it is going to be n log n. Now, after sorting, I'm going to fix my index I, and after that I am applying just simply a two pointer approach. So two pointer approach is going to be take how much time of n, right? Here we are only ignoring the duplicates, so no need to worry about that why are we using while here. We are just ignoring the duplicates, right? That is the simple case. So the overall time complexity is going to be big of n square, and we are not using any extra space, so the space complexity is constant. Yes, we do have a solution in n square, time complexity and constant space. So that's it for this video, and let's meet again in the next video. Thank you very much.